This is video 11.3, geometric sequences. A few definitions to get us started. A geometric sequence, it's much like an arithmetic sequence. Okay, so it's still going to be a sequence of numbers with commas, except this time the common ratio will be the difference between the two numbers. So basically what we're doing is we're going to take one number and we're going to multiply it by a constant number each time to get your next term. This definition is kind of a layman's term definition because the mathematical definition is a little hard to wrap your mind around. So basically what happens is we have the most basic example I can give is if we had the sequence of 2, 6, 18, and 54. Basically what we do, in order to get from 2 to 6, we multiply by 3. From 6 to 18, we multiply by 3. And from 18 to 54, we multiply by 3. So we're multiplying by the constant ratio to get the next term, and that constant ratio is 3. So how we're going to define the common ratio is what you multiply by. It's the most basic way to define it. Okay, so 3 is your common ratio here. Your geometric sequence, this would be the example of the geometric sequence. So when you're looking at this one, when you're looking at the sequence, and you're trying to find the next term, the first thing I would do, given any sequence, because it may not say if it's geometric or arithmetic, is I would see if the difference is constant. So from 8 to 20, it's 12, 20 to 50, it's 30. So you realize, hey, it's not an arithmetic sequence because we're not adding the same amount each time. But what we are doing is we are multiplying by something. Okay, so a way that you can find this common ratio is you divide term by the previous term. And that's going to give you the common ratio, so we're kind of working backwards here. So if I did 20 divided by 8, it's like 10 over 4, which is like 5 over 2, which is 2.5. Okay, so I took 20, I divided by the previous number, which was 8, and I found that this common ratio is 2.5. So multiplying 20 by 2.5, I get 50. 50 by 2.5, I get 125. And then 125 by 2.5, I get 312.5. This brings us to our key concept. It says the nth term of a sub n of a geometric sequence with the term a sub 1 and common ratio r is given by this formula. Okay, so it's made up of the same variables that we used for the last one. So it looks like this. A sub n is equal to a sub 1. It's multiplied by r to the n minus 1. Okay, so we take that common ratio, we raise it to the n minus 1. And again, n is talking about your position number. Okay, so if we're going to find the 8th term, and we have a sub 1 equals -3 and r equals -2. Okay, if we're looking for the 8th term, that means that n is 8 because it's a position number. So we have our formula here. So we want a sub 8, which just represents our 8th position. A sub 1 was -3, r was -2, n minus 1, so n should be 8. So we take this and we solve it out. We have -3. This is going to be -2, and that's being raised to the 7th power, which equals -128. That's times -3. Okay, so it's a simple plug-in, and now we multiply them, and we get 384. Okay, so we'll go back to our question. It says the 8th term, and we found the 8th term, so we want to do it so we know we did it correctly. Okay, I want you to do this problem on your own. I want you to hit pause and hit resume when you're ready to go. So hit pause now, complete it, and come back. I want to go ahead and jump to this step when going over it and realize that the r is the only thing that's being raised to this exponent. So 3 is only being raised to the fifth. It's not 1/9 times 3 and then raising that to the fifth. That absolutely is not. The r is the only thing being raised to the exponent. When we raise it to the exponent, we get 243. It's times negative 1/9, and that's our sixth term. And then if we're multiplying by negative 1/9, that's the same as dividing by 9. So we get our final answer to be negative 27. And I hope that's what you got. Right? Just like the arithmetic sequence, we're going to write an equation for the nth term here. So I would always write out what you're given. So here you know that this is a sub 1. We can always find r, our common ratio, by doing one term divided by the previous, which ends up giving a common ratio of 4. So we go back to our formula, which says it's a sub 1 times r to the n minus 1, and we plug things in. So notice we're writing this formula for the nth term, so this is for any term n, so we're going to have n's in it. A sub 1 was 12, it's times r to the n minus 1, and that's actually as far as we need to go because we can't multiply anything, we cannot simplify anything out. We just want to keep it like this. I want you to go ahead and write this one, so go ahead and hit pause and hit resume when you're ready to come back. I hope that this is the answer that you got. You will have to find the common ratio of 2. And again, you leave it like this because that's as far as you can multiply it out. Okay, it says find the 10th term, so automatically I'm just going to write a sub 10, and I know that n is equal to 10, so they're telling us one term, and they tell us it's r is 3, so I'm just going to sort out some of this information. Okay, we know that we're most likely going to be using this formula. Okay, so using this formula, if we wanted to find what the nth term or the 10th term was, okay, I'm just going to plug in things that I can plug in. I know the common ratio is 3. And I know that this is 10 minus 1. So basically, if I was going to try to find the 10th term, I would need to find the first term first. And luckily, they give us enough information to do so, because they tell us that the fourth term is 108. So a to the fourth, our common ratio was 3. It was 4 minus 1 here. So the fourth position is 108. And this is, it's multiplying by 3 to the third, which is 27 times a sub 1. And then dividing it out, we find that our first term is 4. Another way you could think about this is if your fourth term is 108 and you had to multiply by 4 each time. If you divided by 4, you could very quickly find that first term. You wouldn't necessarily have to use this formula. You could just take 108 divided by 4, find that answer, divide that by 4, and then divide by 4 one more time to get to that a sub 1. So you have to find a sub 1 at some point. So this is a sub 1 plugged into the formula. And doing the math, we get a sub 10 to be 78,732. I want you to try this one on your own, so go ahead and hit pause, try it, and then come back. First thing you'll want to do here is find what a sub 1 was, again, because if you're trying to find what a sub 8 is, you have to know what a sub 1 is. just like the previous example. So r was 4. It's being raised to this n minus 1, so we're looking for the 8th, so it's 8 minus 1. So for a to the 8th, you should have gotten 16,384. Notice these numbers are fairly large, and it makes sense because if you're multiplying by a number, you're increasing this exponentially. You are getting very large very quick because you're multiplying and you're getting bigger and bigger and bigger. So don't be surprised when you get large numbers on this because it's very possible. Alright, the next one, finding geometric means is the same as finding arithmetic means. So what it's saying is we have a term 2.25. We want the 3 geometric means, which means the 3 terms in between it. Okay, so the way we do this, I would identify this as a sub 1. This is a sub 5. And really what we're trying to find here is, what is our common ratio? Because if we know our common ratio, we can multiply it by 2.25 to get our next number, and we continue to multiply by that common ratio. So, going back to our formula, we know that a sub 5 is 576. So I am going to use that and say a sub 5 is a sub 1, which was 2.25. I don't know what r is, but I know that n is 5. Minus 1, which is 4. Jumping ahead a little bit. Sorry. Okay, so a sub 5 was 576. 2.25 r to the 4th. We divide by 2.25. And we get 256 equals r to the 4th. And now we want to do the 4th root of this. And when we do, we find r to be, so r is 4. Now what we can do with that, now that we know the common ratios, we take 2.25, we multiply that by 4, and we get 9. And then we take that number, we multiply it by 4, we get 36. We do 36 times 4, and we get 144, sorry, 144. Crisis averted. And then we take 144, and we do it when we multiply by 9, and we hope that we get 576. We get 36, 30. And we do, which is good. Alright, I want you to do the next one on your own. 2 geometric means. I'm going to set it up for you. 2 geometric means between these two numbers. Means it looks like this. Hit pause, finish it, hit resume. Find a common ratio first. You should have found your common ratio to be 1.5. And that makes sense that it's a really low number. It's really close to 1 because between 4 and 13.5, there's not a lot of difference there. So when we multiply this, we should get 6, and then we should get 9, and then we should get 13.5 when we multiply it out.